Hey guys, I really hope you had a good fall break and you're ready to get back into it. I know it kind of makes it hard coming back. Hopefully you guys did some things that were pretty fun. Anyway, I will be back next Monday. So I wanted to keep moving forward with our next transformation. So I'm going to have you open your notes to page 58 and we will get into it. All right, the next transformation that we're going to be talking about is a dilation. And a dilation is a transformation that produces, that should say an image, that is the same shape as the original, but it has a different size. Okay, so now, unlike other transformations, a dilation is not considered to be a rigid motion. Because the size and the shape are not preserved. So remember we talked earlier, when you have a translation, when you have a rotation, and when you have a, what's the last one? Translation, reflection, those all produce something that is the same shape and the same size. They are congruent, but a dilation is not. A dilation would be similar, but not congruent. Now, when we talk about where we are dilating from what is called the center of dilation. It is the point where we are dilated from. Okay, now in 8th grade, we only use the origin. So we will only be dilating from 0, 0. A figure that has been dilated, essentially all we're doing, you guys, is we are multiplying by a scale factor. So circle, underline, whatever you need to. This is a really important one. This is how we do it. We multiply by the scale factor. Now, if a dilation is a reduction makes things smaller, right? So if we're smaller, then we have a scale factor that is less than 1. And if we are dilating and getting larger, that's called an enlargement, and that means our scale factor will be greater than 1. All right, now please, please, please remember, you guys, you can tell the difference between the pre-image and the image because the pre-image is only labeled as A. Your image or your copy is A prime. All right, so let's try a few. Okay, number 1, we are going to graph the figure and its image after a dilation with a scale factor of 3. Pretty simple, right? So all you have to do is multiply all of your points, the x and the y, by whatever your scale factor is. This question says dilate by a scale factor of 3. So we're going to multiply by 3. -2 times 3 is -6. 3 times 3 is 9, so that is our first point. Now this one is a little tricky. When you have a 0 here, you have to remember anything times 0 is 0, even if you are multiplying by a scale factor of 3. So 0 times 3 is still 0. 1 times 3 is 3. Then 3 times 3 is 9. And again, 3 times 3 is 9. So let's just see what it looks like when we plot these points. So our first point, J, is -2, +3. So we're going to go -2, +3. There's our first point, and that is J. Our second point is 0, 1, right here, and that is K. And our last point is 3, 3, 1, 2, 3, 1, 2, 3. All right, so our shape, whoops, forgot to label it, is a little triangle. Now when we dilate this by a scale factor of 3, look what happens. Our new point is -6, +9, so we're going to go over to -6, +9. That's our first point, and we're going to label that J prime. Then we have K, which is 0, 3. So notice that we didn't actually move that far from the origin. That is point K prime. Then our last point is 9, 9, and that is L prime. So when we make that, it is the exact same, if I could draw a straight line, exact same shape, just a different size. Now, it's easy to tell if it's a dilation and where the center of dilation is if you were to draw a couple lines from the origin. See how that lines up? Think about a flashlight. If your flashlight was right here and you were making, I don't know how to draw a flashlight, you were illuminating light out of the flashlight, that is where your shadow figure or your shadow puppet would be. So that is where your dilation is. All right, let's move on. Okay, so that is obviously an enlargement because our scale factor is greater than 1. So that's our first one. Our second one is going to be a reduction. Okay, if you want to write reduction right there, kind of helps you know what it is. We're going to graph this figure and its image after a dilation with a scale factor of 1/2. So again, all we're really having to do is multiply all of our points by our scale factor of 1/2. So this time, let's plot our image first. These ones have 4 points. So we're going to go over -8, +6, that is A. Then we're going to go B, which is 4, 6, 4, 6. C is 4, -4. And D is -8, -4. So it looks like it's just a big box. I'll use my straight line. There we go. 1, 2, 3. There we go. All right. Now, when we multiply all of these numbers by 1/2, -8 times 1/2. So you guys go ahead and write your points in. I'm going to write them up here, and then look up to the board and check yours to make sure they are correct. Okay, I have mine plotted, and you will see, oh, sorry, I made that dot a little lower than it should have been. Oh, for the love. Oh, what is happening? Okay. Oh my gosh. Sorry, you guys. There we go. I just accidentally put my dot in the wrong spot. There we go. You can see this is a reduction. It is a smaller image than we originally created because our scale factor is less than 1. Next page. We're going to skip this one. I think you guys are pretty good here, and my graph is a little hard to read. So this is the next question. The question is, how do we find the scale factor? So I know you guys talked about scale factor a little bit last year in Mrs. Johnson's class, but I want you to be very clear. There is a way you can find your scale factor, and there's multiple ways, so you're kind of going to have to use whichever way works for you. Now, for me, the way I like to find my scale factor and the way that's kind of really helpful doing these dilations is you are going to, and write this up here kind of large, you are going to put your A prime over your A. So remember what A prime is. A prime is what? That is your image. And A is your pre-image. Now, one of the biggest mistakes you guys will make is you will flop this. You have to be careful because there is a very big difference. You don't need to write this down. I'm just trying to show you. If you are making an enlargement or a reduction. Now, really quick, back on this other page, when I found my scale factor, let's pretend I found a scale factor, my scale factor is 3 to 1. Now, a lot of kids, the mistake they make is they flip that, and they'll say 1 to 3. That is very different. This one says I am 3 times as big. This one says I am 1/3 the size. So you have to look at your image too and pass the sniff test. Does it make sense? Is it 1/3 the size or is it 3 times as big? So make sure you are getting the scale factor correct and you don't want to flop it. Now, how do we know which one is the image and which one is the pre-image? Remember, you've got to look at that, which one has the prime and which one does not have the prime. So looking at this first question right here, all we have to do is say, all right, well, which one is my image or my copy? And that is A prime. So we're going to put A prime, right, over A. So is this an enlargement or is this a reduction? Any guesses? Well, since I'm not there and I have no idea if anybody's guessing or not, it is in fact an enlargement. So now we got to figure out how much bigger this one is than the original. So I'm just going to pick one of these points. All right, let's pick, I don't know, what is this point? 3, 1. My first point is 3, 1. 3, 1 looks like to me it turns into, I'm going to go over here, 5, 6, 7, 8, 9, what is that, 9, 3. So how did I get from 3 to 9 and how did I get from 1 to 3? It'll be the same number that I multiply by, right? If you look back here, all we had to do was multiply everything by our scale factor. So what number did we multiply by to get from 3 to 9? Right, 3. So our scale factor is 3. All we did was we multiplied all of these points by 3 to get it to be 3 times as big. 3 times 3 is 9, 1 times 3 is 3. And if we were to pick a different point, we will get the same scale factor. So let's try this point just to double check. This one is a -1, +1. And it turns into, let's see, -3, +3. Well, -1 times 3 is -3, and 1 times 3 is +3. So we were correct. Our scale factor is 3. Let's look at this next one. All right, so this one, it looks like our image is smaller than our original. So we are going to call this one a reduction. And we're going to do the same thing to figure out our scale factor. Let's choose a point. I don't know, let's go Q. Let's see, point Q, the original, is -2, +4. Let's see what it turns into. Let's see, -1, +2. Okay, so what number are we multiplying by to a reduction? Okay, so think about it. We know because it's a reduction, it has to be less than 1, which means it's going to be a fraction, right? Okay, so 4 times 1/2 is 2. -2 times 1/2 is also, okay, perfect. So we are multiplying by 1/2. So that is our scale factor. Now let's see if there's another way we can figure out scale factor by using our A prime over our A. Some kids like to use this method, which is perfectly acceptable. let's take this original point here. Now I know that this original point, 3, 1, actually I can't remember, 3, 1 is our original, right? So this one would be our A. And this one, 9, 3, is our A prime. All you have to do, if you like this method better, is take one of your points, either your x's or your y's, it doesn't matter, and put them in your ratio fraction. So A prime is, I'm going to use my x value, 9, and my A value is 3. Well, 9 divided by 3 is in fact 3. Okay, well let's see if it works with y as well. 3 over 1. Yep, 3 over 1 is in fact 3. Okay, so let's try it with the second one and use this second method. Let's take this first point. My first point is again my, I can't remember again, negative 2, 4. Okay, that is my q. And this one is my q prime. So to find my scale factor, I'm going to put q prime over q. Let's see if it works. Q prime, let's do my x values first, is negative 1. My q value is negative 2. Negative 1 divided by negative 2 does in fact reduce to 1/2, so that does in fact work. Let's try it with my y coordinate. 2 over 4, which reduces to 1/2. So that is in fact my scale factor. All right, hopefully you guys are starting to catch on. So those are two different methods on how you can find your scale factor. You can use whichever one, and sometimes depending on which one you feel like using, you know, different scenarios work better for different ones. All right, determine the scale factor for this given dilation. I want you guys to go ahead and try to do that really quick. I'm going to wait like 5 seconds and then I'm going to give you the answer. Okay, so let's do this. I'm going to take, well, see, this one's kind of hard to tell a little bit, but it for sure looks like a reduction, doesn't it? Because my original is very large and my copy is very small. So immediately, I am going to cross off the ones that are greater than 1, okay? Just looking at this one, I kind of can use my common sense to tell what I think it is, but let's just double check here. So let's write the point n. N looks like it goes 3, 8 is my point n. And it turns into, and this one is kind of hard to tell, that's 1, 1.5, so I'm going to say 1.52. All right, because I'm working with decimals, I may want to actually use my second method. So let's go ahead and use our scale factor and put our ratio and put A prime over A. Or in this case, we're going to put N prime over N. Let's use, I don't want to use the decimal, so let's use our y coordinate. My N prime is 2 and my N is 8. Well, 2/8 reduces to 1/4. Okay, now if you guys ever mix those up, and this is what I was talking about with the common mistake, if you forget and put n over n prime, what are you going to get? You're going to get, I'll do it over here in the wrong color, you're going to get 4 over 1. Well, I don't know what happened. You know that 4, oh my heavens, sorry you guys. You know that 4 is greater than 1, so that's going to be an enlargement. So you know immediately that is the wrong answer. You know that it's smaller, it's a reduction, it has to be less than 1. So your answer is going to be 1/4. All right, that is really all there is to scale factor. So go back in your notes to the page where we have all of our cheat sheet rules on, and I'm going to write the rule for dilation for you. It's a lot of scrolling. Okay, for dilation, here's your rule. X, Y turns into, and then I'm going to say K, which is your scale factor, times X, K, your scale factor, times Y. Okay, that is your rule. And then I want you to write that it can either be an enlargement, which is K is greater than 1, or a reduction, where K is less than 1. All right, write that down. Now, I do have a couple of the Alex questions that I was concerned you were going to struggle with, so I wanted to show you how to do them really quick. I think you'll be fine, but I just kind of want to show you a couple methods. This is one of the questions of dilation. Okay, it's going to say, in a scale drawing of a painting, 1 centimeter represents 8 inches. Okay, so here's my scale factor. We can rewrite that if we want to and say our scale factor as a fraction, is 1 centimeter over 8 inches, right? Because you can write a ratio with the dot dot, or you can write it as a fraction. All right, in the scale drawing, the length of the painting is 4 centimeters. What is the length of the real painting? Okay, well, they give us the scale factor to work with, so this is how I like to set it up. If my scale factor is 1 over 8, and I know that the 1 is centimeters and the 8 is inches, I can just line things up. Centimeters over inches. Okay, well, it says in the scale drawing, the length of the painting is 4 centimeters. So is centimeters going to go on top or bottom? Right, it's going to go on top. So now I'm looking for what my painting is in inches. Now we have a beautiful love my math situation. So this is part A. So that's how you set it up. 1 over 8 is equal to 4 over x. Now I just have to love my math. 8 times 4, cross multiply, cross products, is equal to 32. Drop down your equal sign. 1 times x is just x. So x is equal to 32. So my painting is 32 inches. Okay, that's how you do A. So let's try B. The height of the real painting is 48 inches. Okay, so I'm going to use my same ratio here, 1 over 8. I know that it's centimeters over inches, but this time it tells me what my inches are. And that corresponds with my denominator. So I'm going to write 48 on the bottom, and now I'm looking for what is the height of the painting in the scale drawing, looking for x. So let's set up do you guys see how I got that? I'm still doing centimeters over inches, and I'm just lining it up. So let's love our math, because we all know we do. So now let's cross product. We get 8 times x is 8x equals 1 times 48 is 48. Okay, so this makes it a one-step equation, so we need to actually solve for x. Say it out loud if you need to. 8 times x, the inverse of timesing is dividing, so we're going to divide both sides by 8, and we cancel our 8's. X is equal to 6. So our height of the painting in the scale drawing is 6 centimeters. All right, next question. The table below gives the dimensions of a painting and a scale drawing of the painting. Find the scale factor of the drawing. Ooh, okay, we're looking for a scale drawing, so do you guys remember how to do that? All you have to do is put A prime over A. You could also look in the words. Find the scale factor of the drawing. The scale factor to get the, look at this, drawing from the painting. keywords here. So what do you have to do? It's looking for the drawing from the painting. So all you really have to do is go drawing over painting, right? Which actually makes sense because the drawing is your A prime and your painting is your original, your original. So let's try it and see. Okay, drawing, got to make sure you go inches. I'm comparing length to length and width to width, just like I was comparing X to X and Y to Y. So I'm going to put my drawing, which is 12, over 16. Okay, let's just double check the second one to make sure we're right. I'm going to put my 9 over my 12. Okay, 12 over 16 reduces to 3/4. 9 over 12 also reduces to 3/4. That is our scale factor. 3/4 is our K value. Okay, that's how you find your scale factor. So you've got two options. You can put it prime over not prime, so the copy over the original, or you can just look at the words and see which one they want it for. They always list the first one as your prime. Drawing for the painting, drawing to painting, drawing to painting. All right, next one. The table below gives you dimensions of a sculpture and the scale model of the sculpture. So we're going to, again, find the scale factor. So they want to know the scale factor to get the model from the sculpture. So this time we're going model to sculpture. Again, we're going A prime over A. So which one is going on top? Well, model. That's the copy. And the original is the sculpture. So all you got to do is put the model on top of the sculpture and make sure you're lining them up. Length for length, width for width, height for height. So you've really kind of got three options, but they should all be the same. 8 over 48. Then you get 5 over 30. Or you get 9 over 54. Well, what do those all reduce to? If you don't know, put it in your calculator. 1/6. Okay, so that looks like that is what my scale factor is. My K value is 1/6. I know that was a lot of information, you guys. Do your best. I'll be back next week. Please be good tomorrow and have a good weekend.